This is Module 8, Question 3. You have two securities, security F, which has an expected return of 10%, standard deviation of 53%. G has an expected return of 13%, standard deviation of 79%. What's the expected return on the portfolio that has 40% of F and 60% of G? What's the correlation if the standard deviation is 0.35 for that portfolio? I have taken the liberty of writing down the expected return and the standard deviation. I forgot to do the weights. Let's add those. I think it's 0.4 and 0.6. Yes. All right, the expected return is pretty simple. We're just going to do the sum product of the expected returns and the portfolio weights. We'll put that in percent terms just so we have it. And lo and behold, it's 11.8%. In the second part of the question, they give us the correlation as 0.35. And they ask us to figure out the standard deviation of the portfolio. And what we're going to do here is we are going to create a variance-covariance matrix. And to do that, we already have the standard deviation. So if we square this, we get the variance. And just so you remember, the easier way to look at this is to do the covariance between F and F is just the variance of F. And similarly, G and G is just the variance of G. And then F and G are going to be related to the correlation. And so let me see if I can find the page that has correlation. It's not that one. It is in here. Here we go. The correlation, this top term is the covariance, and the bottom term is the standard deviation of A and B. So we have the standard deviation of these. And to get to the covariance, so correlation equals the covariance of, I'll just do an underscore, F and G, divided by the standard deviation of F times the standard deviation of G. So therefore, in order to get the covariance, we are going to do equals that times that times that. Let me move this over here and explain that. So we can rearrange this equation, and we have covariance of F and G equals the correlation. I'll just put F and G, even though it's not kind of up there. And then the standard deviation of F times the standard deviation of G. We have that. We can put those on the diagonals. Again, this is the covariance between F and G here, and the covariance between F and G right there. We need the weight matrix here, and we can do the same thing. So this is and we know the diagonals are the same. The last thing to do is to get the portfolio matrix, and that is just going to be the variance covariance matrix times the weights. To get the variance, we sum the entire portfolio, and to get the standard deviation, we take the square root of that. Notice that we get the same answer that we get here, 58.31%. And let me just walk you through the intuition here. Each of these assets, F and G, will have its own variance. So this is kind of independent. That's the risk that each of these carries. But they also move together. And because their correlation is 0.35%, we have to take into account the correlation between them in terms of calculating the variance. And this matrix notation is the easiest way to do that. We also need to calculate the weights, and so we'll have a weight from purely this asset, a weight from purely this asset, and then the weights together for the covariance of the assets. Once we do that, we just multiply those numbers together and add them up, and we get the variance and the standard deviation when we take the square root. This risk, and notice that you can kind of see you get a kind of in the middle return between 11 or 10% and 13%, and you get a lower standard deviation as a result. So like the standard deviation is only a little bit higher than the 0.53, but it's way lower than the 0.79, and we also got an extra 1.8% return for having held the other asset as well. So the idea here is that diversification helps improve our risk and also improves our return.